Everyone, welcome to the series of O-Level Mathematics Class 9-1 Cambridge IGCSE syllabus. Our today's lecture is about volume of a pyramid. As you know, we are doing different concepts and topics about the O-Level Mathematics Class 9-1 exams and the topics coming in papers. We are seeing these concepts and doing questions that are coming in the exams hopefully. And we are seeing. Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 IGCSE Cambridge syllabus. Our today's lecture is about the volume of a pyramid. We see this concept and we will do questions, the types of questions that are coming in the exams. Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 IGCSE Cambridge syllabus. Our today's lecture is about the volume of a pyramid. As you know, we are doing different concepts and topics related to the exams that. Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 IGCSE Cambridge syllabus. Our today's topic is about the volume of a pyramid. As you know, we are doing different topics and concepts that are As you know, we are doing different topics and concepts about the paper of O-Level Mathematics Class 9-1. We are doing the exercises of these topics that may come in the exams. Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 IGCSE Cambridge syllabus. Our today's topic is about the volume of a pyramid. Okay, so let's start today's lecture. Now, first of all, we have to know about the shape of a pyramid. So pyramid is a three-dimensional shape because as we know that in geometry we have two types of shapes, two-dimensional and three-dimensional. So first of all, pyramid has three dimension, right? So it has height, it has length, and it has breadth. Okay, so this is a three-dimensional shape which has a base with the triangular face, right? So it means that the base of a pyramid is some rectangle, and the faces mean that because the shape has a length and breadth, so this base part covers these two things, the length and the breadth. The interesting things come is about the height, right? So when you talk about the height, so it means that we have some dimension in the upward direction. So this upward direction thing, as you can see, this can make from a triangle. So that is what we call the faces. So this pyramid has a base, this thing, a rectangle thing, right? And these faces are, so what faces are? These four triangles. This is the first one, the front one, the back one is the second, and the left and the right. Right? So we have four triangle and we call them the faces of a pyramid. So these five geometrical objects, right? Four triangles and one rectangle. These five geometrical shape make a pyramid. Under the assumption that we can join them at one point. This all faces is joining on this one point. We call it apex. Call it apex. Okay. The important thing is that for the pyramid, this base which we are in our uh, topic taking as a rectangle, right? For the general pyramid, this can be any polygon, right? So polygon is, so it is a shape with n sides, right? So what polygon we have, it has four sides. So this polygon has a nice name, which is rectangle, right? So in our concept, in our topic, we are strict to this one, that the base is always rectangle, right? But in generally, pyramid can be made from any polygonal base, right? But in our the concept related to our paper, the question related to our exams, they have this special case that the base always remains the rectangle. Okay, now, so we are taking, so first of all, so we are taking the definition of a pyramid as that it has four faces, which is four faces, which is triangle, and one face or called base, which is rectangle. And this is our definition of a pyramid. We are strict to this definition. And volume formula is 1 upon 3 base area multiply with the vertical height, right? So this is the formula you have to know about the volume of a pyramid. Now, you can see that height is this normal from the apex to the base, right? This is height, and the area, you can see that this length and this is breadth. So when you multiply these two things, you got the area of a base, and you multiply this base with the height, you got this thing, base area multiplied by height. And for the volume, you have to multiply this with the constant factor 1 upon 3, right? So these two things, so the area gives you unit, which is in square. The vertical height gives you unit simple. So it means when you multiply them, you got whatever unit, so you got the unit cube. And we know that the volume always has a unit which is cube, right? So whatever answer we got here, we always have the cube rate. So this is the simple definition of a pyramid, and this is the simple formula of for this pyramid. So now let's do exercise 27. Okay. So our first question is about to find the volume of each of these given pyramids. Both all the pyramids have rectangular base. Okay. Now for part A, we know the volume formula for the pyramid is 1 upon 3 base area with height multiplication. So in the first part, you can see that the for the base area, what is base area? Base area is this, right? Length and this breadth. So you have to multiply these two. So 7 multiplied by 4. So you got 28 centimeter and centimeter, centimeter square. So must you can carry the unit with the question. And the height is 6 centimeter. Now 3 1 3 2 2 6. So first thing is you have to multiply 28 with 2. So what we got? 56. right? 56, and the main thing is centimeter square, and centimeter becomes centimeter. So this is become the volume of a param. So really easy. Okay. The second part, which is the same as the first part, the C part, you can see now the pyramid is little tilted. The above four now triangles are not symmetric. Here the four triangle are, you know, it's like it's symmetric, although it's not, because this one and the back one is symmetric, and this one and this one is symmetric because of this length, right? It is 4 centimeter length, so this and this 4 centimeter, and this and the back one is 7 centimeter. Now here you can see that all fours actually are they're different because the length is remains same, but now the apex is not in the middle, but it is somewhat tilted on the right direction. So here in this case you can see the base area is, so for the B part, again volume is 1 upon 3. Now for the base area I am just using BA multiply with height, right, for H. Now here the height, you can see that the height of this triangle, right? So we can use this triangle height as the height of this, because we know that when you sketch the parallel line into this, so the both have the same length. So actually now for the height you have to use the length of one triangle, which is 12 centimeter, 1 upon 3 as it is, and the base is nothing but 20 into 13 to 20 into 10 200 and 6 to 260 centimeters, right? So you have to now multiply these. You got centimeter cube. Multiply these two, divide by 3, and you got this answer as well, right? So this is easy as well. Again, the D part is same as the part C. Now here you, for the height you use this 9 centimeter. Actually this is the height of what? The triangle. This triangle. This triangle. This is the height of this triangle. But when you draw a parallel line with the base, so you got the same height line, right? So we are using the height of a triangle as the height of the pyramid. So actually you can see that the maximum height of any triangle is actually become the height of the pyramid, right? Okay. Now part D and E are similar to part A, B, and C. So try it out by yourself. So the question one is complete. In question 3 we have need to tell that you have 6 pyramids which have a height that is half the side of the square base. Okay, so actually they are saying that we have a pyramid 6, and when we join them together we got a square. So you can see actually in this figure you are seeing a cube, right? This is a cube, but they are saying that this cube is actually made up of 6 pyramids. So it means that actually we have like this. Suppose this is one pyramid. Likewise, we have 5 more, right? So these are these pyramids we have. So I am just making it to make the intuition that okay, this 4 when you made glue to them, right? So these are 4. So we know that actually our cube has 6 faces, right? So this has 6 faces. So actually the phase 1, phase 2, 3, 4, 5, and 6. So 4 I make, right? This is 1, 2, 3, 4. So we join them, and now for the third dimension, and for to the front one we have 1 pyramid, and for the previous the behind one we have one pyramid, and we add them all these six pyramids, we got a cube, right? So they are saying that we you have six pyramids, right? And which have height that is half the side of the square base. So here each pyramid, suppose this one, the first one, they are saying that this pyramid has half the side of the square base, right? So the height of this here to here, we know this is the height. So they are saying this height is half of what? The side of the square base. So this is the base. This thing is the base. Let me change to color. So this thing is our base, right? So whatever the length of each side. So let's say the length of this base side is A. So it means height is half A upon 2. So they are in question, they are giving this, that you have a six pyramids, 1, 2, 3, 4, and 5 and 6 in the front and in the back. We have six pyramid, and each pyramid, every one of the pyramid, both all the pyramids are same, all six are same. And for each pyramids, their height of is every pyramid is actually the half of the side's length. So it means that this side, we suppose that the length is A, so it means the height is 1 upon A, and it is similar to all the six pyramid. Okay. Now in part A, we have to explain how they can fit together to make a cube. So we already did that how we can fit together. We can fix the apex of each triangle of each pyramid, right? So we have six pyramid, these are the apex of them, right? So we can fix the apex, or you can say join the apex of each pyramid at one point, right? Like, so this point, we join all together on this point. So at this point, which is a center of a cube, right? Right. So this, when you join these all six at this point, so this whole figure, the figure you get is cube, right? And this point is become the center of the cube. So the part A is really easy. So we just have to explain how we can join them. So we join the apex just to one point, and we got a cube. In part B, they are saying that how does this show that the formula for the volume of a pyramid is correct? So this scenario, that you have six pyramid, you join them together, you have a cube, right? This scenario give you that the formula of a pyramid, which we learned part B. So we learned the formula of a pyramid, right? The volume of a pyramid, we learned the formula is 1 upon 3 multiply by base area multiply with height, right? So in for by this scenario, we have to prove that this formula is correct. Right? So we have to prove this. This is our task. And what is given to us is this scenario, right? So for this, first of all, let's see what we are firstly given. So you can see that we are given that base side, we take base side equals A, right? Because in this, I already explained that to make the formula of a height, we you call it any A, B, C, D, X, Y, any variable. So we take the base height is A. So it means the height of pyramid is half A, because it is given to us that the height is half of the length of the side. Okay. Now we know that when we join all six pyramid, we got cube. So what is the volume of a cube, right? Volume of a cube. What is volume of a cube? Since each side is A, right? And when we join them together, we got this cube. So this side is A, this side is A, this side is A. So volume of a cube is, we know, length, breadth, and height. So A multiplied by A multiplied by A, right? So we got A cube. So this is volume of a cube. Volume of a pyramid we got from this as, so now volume of a pyramid is 1 upon 6 A cube, because this cube has in it 6 pyramid. This cube has 6 pyramid in it. So which means when I divide this, the volume of this cube with 6, I got the volume of one pyramid. So now volume pyramid is 1 upon 6 A cube, right? So for one pyramid, we got the volume. So this is actually the volume of a pyramid, which is 1 upon 6 A cube. So if you can see that, you can write this 1 upon 6 A cube is like this, 1 upon 3 A square into 1 upon 2 A, right? So this disjointment of this term, right? What I did, 1 upon 6, I write 1 upon 3 and 1 upon 2. And for the A cube, what I did, I make A square and A. So when you multiply all these, you got again 1 upon 6 A cube back. But why I did this? So you can see now that 1 upon 3 is our factor 1 upon 3, right? It is constant factor. This A square is what? Area, because we have these square, right? So when I got just only this square, and I am talking about the area of this, so this A and A is A square. So it means this factor is base area. And this half A, according to given condition, this half A is what? Height. This is height. So this is H, height. And now you see that from this, you got the formula of a volume of a pyramid. So it means, hence proved that volume formula of pyramid is correct, because we got the same formula that we take previously. Is correct. So this question is important because for different types of figures, we always have this type of question that find out that the formula of the volume of the shape or the formula for the surface area of the shape is correct or not. And we are given some scenario in which we have to look this formula, right? So the question is complete. Now let's start question 4. Okay, so question 4 is saying that we have the glass pyramid outside the Louvre Museum in Paris, and it was built in 1980s. It is 20.6 meter tall. Okay, so we have the pyramid, something like this, and this height of this pyramid we are given 20.6. So this height is 20.6. and the base is a square. So we know that the base is a square. It means the side of one side is 35 meter, right? So and this thing is again in meter, 20.6 meter. So if the base is the square, we know this thing is also a 35 meter. Okay, so this is what we are given. Now suppose they are saying that suppose that instead of pyramid, the building was a cuboid with the same square base and a flat roof, and the volume is same. How high would it have been? So it means what they are saying that if we make using this structure, if we make a cube, right? We make a cube using this. So how high our cube is, we have to find this. So it means we have this structure and we have to convert this structure into a cube, right? So we have pyramid structure, and when we convert this into a cube, how tall the cube we have. Okay, so it means so what we have to do is actually first deassemble this, right? So we deassemble all the four triangles and the base, and then join them together so that it becomes a cube instead of a pyramid, right? So we have to do this now. So we have to find this height, and for this, first of all, we have to find the volume of this pyramid, because the only thing help us in this situation, they are saying that the volume is same. So whatever volume this pyramid has, so this volume of a pyramid and this volume after you when you deassemble all the parts of the pyramid and then join them to make a cube. So the thing which is remains same, that when this structure you have, the volume it has is, and when you make the cube from this, so the volume of this cube both remain same. So the volume remains same in both the structure. Okay, so let's find first the volume of both these two, and then we equate them and find the height, right? And always do the question using this method. Let's first find the volume of first shape and the second shape, and then equate them with each other and find the unknown. Like this we are doing here. So first of all, let's find the volume of a pyramid. So I am writing in a subscript pyramid. So volume of a pyramid is 1 upon 3, right? Base area multiply with the height. So we have 1 upon 3. Base area is 35 meter and the 35 meter. So 35 meter square, right? Multiply by our height is 20.6 meter. So we have 1 upon 3. Now the let's do 35 meter square, right? So it gives us 35 into 35. So we got 1,225 meter square into 20.6 meter. So into 20.6, we got 25, 25 divided by 3. So we got 84111.666 meter cube. So this is the volume of a pyramid. This is one thing we got. Now, second thing to do is find out the volume of a cube. So volume of a cube, we know length, breadth, and height, right? So the base remains same because we are given that the when you make the cube from this structure, this cube have the same square base, right? So this base has same like this. So this base is 35 meter this and 35 meter this. So it remains same. 35 meter, 35 meter. So length is 35 meter into 35 meter. We don't know the height. So this is h. So volume of cube is v cube is 35 into 35, again 1225 meter square multiplied with h. Okay, so we got these two things. Now the next thing is to equate both of them. So what we mean by equate, that the volume of a pyramid is equal to the volume of a cube, right? So volume of a pyramid is, what is the volume? We got pyramid volume is, so we can write this as well, or we can write this thing to make the calculation easy. So like I am writing this thing, 1 upon 3, 1225 meter square into 20.6 meter. So uh, by purposely I am doing this, although we have this answer, so we can write this as well, but by purposely I am writing this. Why, you can see in a bit. And the volume of a cube, what we got, 1225 meter square multiplied by. So this 1225 meter square is multiplying here for when it go to the left hand side, it divided by this 1225 meters into 20.6 meter is equal to h, right? So this cancel out, this meter square to meter square cancel, 1225 1225. The only thing we got, 1 upon 3, 20.6 meter is equal to h. So when you divide 20.6, right? So we can divide 20.6 divided by 3, what we got, something 6.86 meter. So this is our height, and the question is complete.